are using the really bright yellow because it almost matches all of my math quizzes.
Oh, cool. It's interesting to read the backs of these things sometimes. We get like all kinds of stuff on it.
On the back of those?
Yeah.
What do you find on the back of those?
Oh, I'll find like phone numbers and little notes of things to do and stuff like that. You never know. And sometimes in computer science homework I get like people's calculus homework and things. Occasionally physics problems.
That's not as weird.
What?
That's not as weird.
That's not as weird, yeah.
Even great physics problems.
Yeah. All right, so what I wanted to do today was talk about whatever questions you have, and then I wanted to talk through some ideas on keeping track of the inventory for PA5, because I'm getting lots of questions on that. And then at about 11:40, Chris Height is going to come in and do his little 10-minute talk that he was supposed to do last Wednesday when I canceled class on this teaching kids to code program that he has going and looking for people to help with that. So that'll be at the end of this class and then at the beginning of the next class. So with that in mind, any questions up front? And then we're going to talk about a review, but we'll do that today and tomorrow. And sorry, one more thing. Fridays have been optional classes, right? But since PA5 is due on Friday, I'm planning to go through the code for that and talk about questions on PA5, right? So if you want to find out about PA5, come to Friday's class. So other than that, it'll be kind of open lab again.
The final, that's on Wednesday?
So there's a final on Wednesday at 11, there's a final on Monday at 12. And if you want to come to a different final from the one you're normally coming to, that's fine, but shoot me a note and let me know, just so I...
2 hours?
2 hours, yeah. All right, go ahead, sorry.
That's fine. So what would be the best array to save all the strings for the name of the item?
Use a structure.
Yeah, it's easiest if you make a structure. So have a structure that has the weight and the value and the name, right? And one of the reasons I gave you these simplifying assumptions is so you can do things like this. Right, so you can make it a fixed length. You don't have to worry about dynamically allocating memory and so on. And then you can have a struct item. Did I limit it to 128?
Yeah.
So there's your array of possible items. And as usual with C arrays, we're able to keep track of how many things are in the array. And then you can pass that to a function that reads your knapsack.data file, parses it, checks the syntax, loads up these arrays, and returns, if you like.
And then for like a path, so once you find the optimal number of each thing to put in the knapsack, would it be beneficial to put inside of the actual structure definition, like a count of how many of those things there are, or would that feel counterproductive maybe? I don't know. I'm trying to think of.
You could do that, but as we're going to see, right, one of the tricks to making this inventory business work is making sure you're using local variables as much as possible. And your items array is probably going to be global, right, or maybe something that you pass, but I don't know if you necessarily need to localize that. But that could be one way to do it. You could throw a count in there, like optimal count or something, as long as you're prepared to have multiple copies of this array. Yeah.
So do you say we need to use caching? And if so, what's our maximum value?
Maximum capacity that you're going to have to work with is 1024.
Okay.
So you can make a cache of 1025.
That wasn't in the document.
I think it's in a note though.
It says the maximum weight of an item.
Yeah, but
I didn't see it.
Yeah, it's like about 10.
this is where I got a little sloppy-ish. Note. There we go. Yeah.
On canvas.
Yeah. How quaint, I know. Yeah, so I fixed it in the PDF, but I had already posted it, so. Yeah, so maximum capacity is 1024, so that lets you use a fixed size cache for your results.
Actually, that is-
I think I figured out the freakiness on the screen yesterday. Oh, I just did that. It's actually flipping between full screen and not quite full screen. And if I don't touch the mouse, I think it's stable. Yeah.
Do you want us to check if the name is in like the knapsack, that data is, if the name is a number too?
If the name is what?
A number. Like I tried like several cases to see if I could break it,
Mhm.
and I could put like 3 numbers in the line, and then it would put like the number.
Yeah, that's
eight.
fine. We could have an item called
Maybe.
37.
Yeah.
I
You don't
wanna
want us
buy-
to
That's
try to
fine.
fix it?
You don't have to error check that now.
Okay.
I guess that would kind of make it more flexible too, because you could be using this for like ID makers.
Yeah.
like kind of-
Yeah, yeah. Generally, when one talks about a string, it's not assumed that it's just a string of letters or things that look like variables. It could be a string of anything. So yeah, that's perfectly fine. Don't worry about it.
So the string is kind of like anything goes, or what?
Yeah.
Does a string not?
Anything it says in there, it doesn't contain spaces. And that's another nicety nice, because if you scan F with a %S, right, well, what is a string? It's anything, but %S will stop when it gets to a space. Bless you. So that'll you can just use a %S and store it in a string. I used to work on stock data, and the code for AT&T, this exchange code, was just the letter T, right? Because they were one of the biggest names at the time, and there was a maximum of 4 characters for these exchange codes, so it was actually T followed by 3 spaces. And one day the vendor changed something, and they wanted a different version of AT&T, and they called it space 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 T. You want to talk about code breaking mercilessly? Because a lot of things will ignore those leading spaces, and we suddenly had 2 different companies that were like being treated as the same. That was a little bit of a nightmare. So
Wait, those are 2 different companies? I thought they were both AT&T.
they were, but there was a before and an after some event, and so they had
But don't you
separate
want
streams
them-
of data associated with them.
Don't you want them treated as the same?
In some cases, yeah, but in some cases, not.
Like, why
In
not?
the cases not are when you're comparing history, right? And you're finding that, so if you treat them as the same company, you get like duplicates, for example. And this was split related, so we had different
Okay.
split histories. And yeah, it was kind of a nightmare.
Wouldn't it kind of be like if you have an American dollar bill and you go to Mexico and try
Mhm.
2 different banks, one of them will cash it and the other one won't.
Yeah,
Or it'll sometimes work, but sometimes it won't.
yeah, yeah. Or you can do arbitrage. All right, so yeah, we're ignoring all those things. We're assuming no spaces, and whatever you get for that 3rd column, that's the name of the item. And I'm not going to give you anything weird like, you know, an escape character or something like that. Other questions, comments? All right, let's talk about the inventory business.
Yes, just to make sure,
Yeah,
the weight of an item can't be 0, right?
the what?
The weight of an item can't be 0. Right?
We're not going to let the weight be 0 or negative. We're not going to let the value be 0 or negative.
Okay.
Some of those are annoying, and I think some of those actually break the algorithm.
Well,
I
was
think
just
negative
thinking, like,
values
you
might.
don't win zero, just infinitely go. Or,
Yeah, you'd have to put an extra case, and 0 is a nice case to say no solution here. So, yeah. So weights and values will always be positive.
So you're not gonna test those? Or are you gonna test those?
I don't think I'm going to test for negatives, but I'll test for like haha, you know.
Okay.
So like if it's invalid, if it's not an integer. But no, I won't test negatives or complex numbers. All right, so all right, so basic recursive function, right? I ignored the edge case. Oh, there's pi. Pi day.
I'm sorry.
Okay, I'm going to get them between classes.
They have a lot of pie.
Okay, good. It looks like you got banana cream. I'm going to stare at it while I lecture.
You should
I'm
take
trying
a
to get
field
rid of it
trip.
as soon as possible.
Take a field trip, get some pie.
Yeah.
Field trip some pie.
So classic example of a recursive function, fib n returns fib of n minus 1 plus fib of n minus 2. Okay, and I'm ignoring the base case here. We'll just assume there's a base case. Right. All right. Now, suppose we did this with a global n. Right. So we set n equal to 10. And we call fib. Well, what's going to happen? Inside here, we're going to try to calculate fib of n minus 1. So we're going to do something like n equals n minus 1. And then we're going to call fib. And then we're going to decrement n again. And we're going to call fib. Right? But when we return from here, our value of n is going to have changed. And when we call fib in here, our value of n is going to change. And it's going to change all the way down to where it gets down to a 2 or a 1, our base case. And we return. And then when we come in here, we're not going to be doing 10 minus 1 minus 1. We're going to be doing whatever the last value of n was. Right? So recursion usually does not work if you have global variables. Now, our cache that we're using for results, that's a global variable. But that's not really part of the recursion. The general way that we're doing caching is the following. So function of n is cache n set. If it is, return n. Otherwise, do some recursion. Figure out what your final answer is, and then at the very end of all of that, save it. Okay, that's really how we're effectively doing this caching in the knapsack, even if you're scrambling things up somewhat in here. All of the recursive stuff happens in here. We use this global array at the beginning of our function, and then we modify it at the very end, but we don't use it inside these recursive calls. Right? And the only thing we do with it here is we check to see if it's already been set, and if it is, we just return. So that's a safe global to use, even though we're doing recursion. We don't need multiple copies of it, which is good because we don't want multiple copies. But in general, if you have global variables and you use them in your recursion, you gotta know that that's what you want to do, right? Like if you want to count how many times you call a function, you can make a global, you can increment it in the top of your function, that's great, okay? But with this inventory business, if you have a global array that's recording what your best inventory is, here's what happens. We have this inner for loop. So it's something like for item equals 0 to number of items minus 1. Temp equals value of item, and this is all max val of some capacity. So temp equals value of item plus max val of capacity minus weight of item. All right, that's our basic dynamic programming, right? So we iterate across all the items. We calculate the best value we get if we start with that item number. And if that's better than our best solution overall, then we record that best solution. Initialize that to 0 or negative or something. All right, so we want to keep track of an inventory. If we have a global inventory array outside of this, every time we call max val, that's potentially updating that global inventory. So let's say we want to find max val of 20. And let's suppose our items look like this. So here's 2 with a value of 10, here's 3 with a value of 20, and here's 5 with a value of 30. All right, so to find max val 20, we're going to compute the following things. We're going to compute the value of the first item plus max val of 18, value of the second item plus max val of 17, and the value of the third item plus max val of 15. And one of these will give us our best value. Suppose it's this one. If we're storing the best inventory in a global, when we call this version of max val, that's going to update our global inventory array. And when we come back and we say, okay, here's the maximum value we can get, we don't know what the inventory was that gave us this max value. Right? We've disturbed it by calling max val 15. And so it's likely that your maximum value inventory is going to be corrupted if you have it as a global. So if you make it a local, right, every time that you call a function, your local variables get pushed on the stack. They're saved. They're not affected by the function that you're calling. You go ahead and you do your things, you return, and then they're removed from the stack and they come back into existence. And they're exactly what they were before the function call. All right, so what do we want here? So here's one way to do this. Make yourself a structure. So this is what max val is going to return. It's going to return a structure that contains multiple fields. One field will be the maximum value that we can get from a bag of whatever capacity we sent to that function. The other has to be the inventory. And one way to do an inventory is as an array. Yeah.
I know this might be a stupid question, but like, what does an inventory mean? Like, what are you referring to?
All right, that's what I was about to write, so it's
Okay.
it's definitely a good question. So here's the idea. So element 0, I'm going to store the number of store how many of item 0. And element 1 is going to store how many of item 1 and how many of item 2, and so on. How many of these give us the maximum value? Make sense? Okay. So you got to initialize some things, right? You got to have some things set to 0 and so on. And now maxval is going to return a struct answer. And if I return a struct answer as opposed to a pointer to a struct answer, it'll actually return 129 integers. Okay? So I'll get back a structure that has a maxval and then 128 item counts. And you can treat it just like a regular variable. I can say, struct answer, this answer, and then I can say this answer equals maxval, parentheses, capacity, et cetera, and it will bring back that value. And I can say best answer equals this answer, and it will copy all of those 129 integers from this answer to the best answer. So you can treat it just like you do your temporary best and your actual best inside the loop. And the compiler will write code to make the right things happen. So let's see what happens. So go back to our loop. We're inside this loop. We're going to loop across the 3 items. We're trying to find maxval of 20. Okay, best equals 0. We also need to know what the best inventory is. So if we're doing this as a structure, well, I don't want to get bogged down in C because there's no need for that. But let's break apart the structure. So best equals 0, best inventory is just an array of zeros. Okay, we don't have a best answer yet. All right, so we're going to start off with item 0. It weighs 2, it's worth 10. So the value that we can get from putting that first item in our bag is 10 plus whatever maxval of 18 is. All right, we call maxval of 18, and this is going to return 2 things. It's going to return, say, best value equals, I don't know, 100, and best inventory is, and I don't know, it's going to be, let's just say, 1 of item 1, none of item 2, and 3 of item 3. Okay, so this is item 1, 1 of the first item, 0 of the second item, and 3 of the third item. Okay, so we're returning an integer and an array from maxval. All right, so our temporary best value is the value of the item 10 plus the maxval of 18, which is 100. That's 118. Okay, so temp equals 118. And the inventory corresponding to that is what? The inventory corresponding to a maxval of 18 is 103. If we start with item 1, then we get $118 out, right? And what's the inventory that gives us that? Increment your count for item 1. Right, so 2030000. And that's our best solution so far because it's our first solution. So we want to save the 118 and we want to save this inventory in some local variables. All right, now we call this max val with a capacity of 17. And let's say that max val of 17 returns the following. Let's say it returns a maximum value of 90 and an inventory of 140. Okay, 1 of the first item, 4 of the second item, none of the third. All right, well, 90 plus 110, 90 plus 20 is 110. So the solution we're getting here, where we're starting with the second item, is a maximum value of 110. And the inventory that gives us that maximum value is the inventory that gave us a max value for 17, plus 1 more of the second item. So we change this to a 5, and our inventory is 150. Got the idea what I'm doing here? So max val is returning a best value and an array of how many of each item you have. And if we're evaluating item 2's benefit, right, putting item 2 in our bag first, whatever gave us the max value for 17, add 1 more item 2 to that inventory. That's how we get this max value, 110 in this case. And that's suboptimal to 118, so we don't care about it. We're not going to use it, right? So we might calculate these things, but we're not going to use them. Now go on to the third case, and let's say max val of 15 gives us 100. And let's say the inventory for doing that is 5 of item 2 and no other items. So the max val we can get if we start with item 3 is 100 plus 30, so that's 130. And the inventory that gives us that 130 is what? You got it. Right? Take the third item and increment it. And we compare that to our best value, which is 118, and this is better. So this is the solution we want to remember at this point in our loop. And we keep iterating over the items, and at the end of this loop, whatever we recorded as the best value, we've also recorded its best inventory. And we throw that into a structure, and we return that as the result of max val.
What if we find 2 that have an equivalence value?
Doesn't matter, you can take whichever one you want. So it depends whether you use a greater than or a greater than or equal to in changing your best. You can do either way. All right, so complications, you got to return a complex thing from max val, not just an integer, but an integer plus an array of how much of each item you want, the inventory. And you can do that by making a structure, or you could pass the inventory to max val and have max val update it as an argument, but structures are going to be cleaner, partially because you also need to cache these. The next time that I want to find a max val, if I'm recursively calling max val of 20, I don't want to go through this again. I want to just read 130 out of my cache. But max val has to also return the inventory, so I've got to cache not just the max value, but the inventory that gives me that value. So your cache, which is an array of somethings, right, is going to have to store more than just integers. So there again, if you've got a structure that stores an integer and an inventory, you can just make an array of those structures. That's your cache.
Or you just have 2 caches.
Or you could have 2 caches, which is basically parallel arrays. But that second cache is going to be an array of arrays, and that trips people up sometimes.
Basically 3 arrays.
Yeah. All right. I think that's the guts of the details for adding in inventories. And my suggestion would be go through this on your own, right? Make absolute peace with what it is you're trying to do before you code it, right? Because coding it and staring at it and then trying to figure out what you're trying to do is not fun, right? So figure this out on paper first. what's the actual algorithm here? And you've already got something like this, right? If you've got this working without the inventory part, you've already got something like this in your code somewhere, right? The central part of maxval is a loop that iterates over the items, finds the tentative best value, compares it to the running best, and at the end, you've got the absolute best value across all your items. You return that, do some caching in the beginning and the end. So you've already got this framework set up, right? So adding the inventory is possibly just changing what maxval is returning and adjusting your code to pull apart the right pieces and such. And obviously it helps to like have multiple versions of your code, right? Make a new directory, copy everything over to the new directory, start working on that. So that if you end up going crazy and like writing poetry in the middle of your code or something, right? You can go back and find the original version. I've actually recommended putting poetry in code before, so it's not a bad thing.
Write code to write poetry for you.
Yeah.
They can do haikus probably.
Yeah. Haikus are awesome. I know someone who wrote a whole book of haikus about Godzilla, but he did it with 757 instead of 575, which is actually a thing, but it's not as popular a thing as a haiku.
If you're ever having trouble finishing your haiku, just remember, thank you very much.
There you go.
It's a good ending.
Yeah. I used to write really scathing haikus about my corporate job that I really hated, and that was a coping mechanism for a while. Just wrote like blistering haikus about it. I think it's called Haiku Corp. It's somewhere on the web.
Haiku board?
I think so, yeah. All right, so other questions? Are most people here planning to come to the regular exam for this section? I'm just trying to figure out how many of each to make. This class would be Wednesday at 11. The 12 o'clock class would be Monday at 12.
What's that regular exam?
What's what?
What's that exam?
I just meant you're in the 11 o'clock section. Are you planning to come to the exam that's scheduled for the 11 o'clock section as opposed to the one that's scheduled for the 12 o'clock section? So.
Still trying to decide when you're eligible for test on Wednesday.
Okay, I'm gonna make extra copies of the Monday one just in case. And remember, I may not be here Monday because I'm on call for jury duty. So if I'm not here, Scott will administer your exam. So.
What would be going over? Is there a, I haven't looked at Canvas, is there a list of?
There is. We can start that right now if there's no other questions.
Oh, and all the quizzes are due Friday.
And all the quizzes are due Friday, yeah. So.
Just thought I'd throw that out there.
Yeah, it popped up on my Canvas recently under like upcoming. So. So yes, on Canvas under final exam, there's possible exam topics. That's a hopeful title. Yeah.
Sorry. I'm later application.
No, go ahead.
No, I mean for the P5.
Mm-hmm.
You already mentioned about like ask questions, something like
No, can we use modular to do it?
Modular
for the
percent sign?
For the inventory.
Yeah.
For return. Would you take off points if we use modular?
What do you mean? How would you use modular? Like in what way?
for example, if I input 9 and like n minus n modular the best item,
Mm-hmm.
and only like that number minus remainder and divide like some best item rate,
Don't know if that works.
and it will be the number of some item.
Yeah, that sounds like a greedy approach. And the greedy algorithm generally won't work for Knapsack. It will work in some cases, but you can usually construct cases where it won't. Sounds like you're trying to say how many of this item could I fit in the bag, right? And then use a modular to see how much weight you have left, and then fit into that. I don't think that's always going to get you an optimal solution.
I had a question about K5. It would just be kind of like a slight modification of the way to add. Could you have in your global cache, could you have a flag for best item, and then on the max value return, whatever has the best value, you tag that with the best flag, and then you go back through it at the end of every max val call and add. I guess it would just be a way to not return an array. And then
Yes, you can store the best inventory in the cache and get away without returning the best val. That works. That's what I did in an earlier version of this, but then I changed it to structures to talk about it. Yeah, that's a good solution.
You also mentioned, like, if you were going to be using like a double array, like I had the idea, like you had the structure answered, and I had the idea where you could just bypass that and have all the items start at index 1 and have the max value in index 0. And then you were also mentioned that at the beginning of your recursive function, you could just increment how many times it's gone through. So when you found the best value, then you could do a flag like he just said. And then once you've hit the end of it, you just go to the index with that flag and you have your answer there.
Yeah, that should work. This is a cool idea. This idea of so we use that first element of the array to actually store the max value. And then we use the remaining 1024 elements to actually store the count of each item that gives us that max value. That works well. What are you really doing here, though? You're really putting together a structure like with your own bare hands.
Yeah.
Right? This is what a structure is. It's a
Essentially,
continuous
that's what I
block of
realized
memory. Yeah.
As you were writing out the structure answer, it was like, it's basically the same thing.
Yeah,
as my
it's
deal is.
exactly the same thing, except you're doing the work instead of the compiler. But if you were doing this in assembly language, right, that's how you would make a structure. Or if you're doing it in Fortran or something that was unstructured, you could simulate a structure like that.
It's
So
all the same
that's a
number
cool
of-
way to think about it.
Same number of bytes.
Yeah, yeah. Nice, I like that. Anything else? All right, let me see if Chris is on the hallway there. Oh, there you are. Hey. All right, well, I will let you come on up. And I will turn off the recorder, unless you want this recorded and broadcast on YouTube.
No, I'm all right.